So let's look at some problems where we're finding derivatives involving natural log. So let's first consider the example here, ln of x squared. ln of x squared. So our rule for the derivative of ln says, hey, you're just going to divide by the stuff inside, x squared, as is the case here, and then multiply by the derivative of that stuff up top. So we'll have 2x over x squared, and we should always simplify fractions, and so it'll actually be 2 over x. So it turns out derivative of ln of x squared is 2 over x. Now, let's consider a second example here. What if we have x divided by ln of x? X divided by ln of x. Well, that's a quotient, so nothing new. We're going to use the quotient rule. That'll be bottom, ln of x times derivative of the top, minus the top, x times the derivative of the bottom, all over the bottom squared. And then we just go through and simplify. Ln of x times 1 is just going to be ln of x. X times 1 over x, they're going to cancel out. That's just going to be 1. So we're going to have ln of x minus 1 all over ln of x quantity squared. Now, quick little note here about this first one here, f of x equals ln of x squared. We could have used our properties of logarithms and rewritten that as 2 ln of x, and then said, hey, the derivative of that's just 2 times ln, so that's just 2. The derivative of ln is 1 over x, and we get to the 2 over x that way as well. Now, in this particular example here, it really didn't make too much of a difference. It wasn't a lot more work, but we are going to see some examples where working with the properties of logarithms to rewrite the expression in a simpler form is actually going to be pretty beneficial to us. We're going to see that in some upcoming videos.